So the first one, you are given the conic section, um, which is 5x squared, uh, 5x squared plus that's 9y squared minus 18y. Okay, this was equals to positive 36. Okay, so now what the question was asking of us to do, first of all, is saying find the center and the foci of the conic section. So what it is here is that for me to come up with the center and the focus or the foci is just a group of the focus. If remember, like you have two of them. If it's an ellipse, you have two focus that you have, which is the f1 and the f2. If it's the parabola, you only have one focus. If it's the hyperbola, you have two, which is f1 and f2 as well. For the circle, it does not have a focus. That's why you observe that a circle has an eccentricity of 0, because there's no focus. What it means is that if you have your eccentricity of the circle being equals to 0, remember to say eccentricity is nothing but over c over a, okay, of which your c for the circle is equals to 0. Why is it 0? Is because your value of a is equals to your value of b. So if you say c squared is equals to a squared minus b squared, or it can be the other way around where you say b squared minus a squared. So you observe to say if your value of a and the value of b are the same, it simply means that you're going to get a 0 for the c. That's why you have the eccentricity of the circle being equals to 0. I hope that is making sense. So what we do on this part of the question is all we have to do is just to complete the square. Okay, all we have to do is just to complete the square. So completing the square is very simple. So you are given this as a general equation. You don't yet know whether it's a parabola, it's an ellipse, or anything, not until you complete the square. But of course you can decide to use the discriminant test, but it only tell you the type of conic section. It don't really give you anything else besides the nature of the conic section you are dealing with. But everything else, the focus, the center, you are unable to find it using the discriminant test. It only helps you to understand before you even do anything the type of conic section that you have. Okay, so if I had to complete the square for this one, you observe to say you're only completing the square for the y part. Okay, here's how you do it. So here you have your 5x squared plus. So what you do here is to complete the square. I'll try to take this step by step in case there's anyone who doesn't understand how it comes about. This is going to be like 9. Then you're going to factor out. You're going to make sure to say this variable that you have as the y there, it needs to have a coefficient of 1. Okay, so I need to factor out the 9. Even if there was a, okay, just make sure to say the coefficient of y at this point is a what? Is a 1. Are you able to see what I'm writing? Okay, good. Okay, so here you're going to have y squared minus, so you observe to say if you have factored out the 9, you're going to put 2y there, and that will be equals to positive 36. Okay, you have positive 36 there. Then for this part, this is just going to be something like, it's still going to be 5x squared um, okay, so we still have 5x squared here, then we say plus what do we have here? So this is going to be 9y squared minus. So how this one is going to be when you complete the square is that when you're completing the square, just multiply the b term by what? By minus 1 over 2. What do I mean by the b term? Why am I getting the fact that I'm using the b term? So what it is that if you have a quadratic function that is ax squared, that will be plus bx plus c. So what you do is that get your b variable, b term, which is that one there, multiply it by 1 over 2. And that's what you're going to use when you're completing the square. So in this case, my b term, um, my b term, if you observe, is minus 2. So I say minus 2 multiplied by 1 minus 1 over 2. Minus 1 over 2 there, you're going to get positive 1. Okay, so this is, you're still going to write the 2y here. then you're going to say plus, that will be positive 1 squared minus positive 1 squared there, then that will be minus 1 squared again, then you close, that is equals to 36. So I know there are people here who know the shortcut of completing the square, but I'm trying to take it step by step in case there's anyone who doesn't understand how to complete the square, or maybe they are forgotten. I believe you did this at first here. So you still have your 5x here, 5x squared plus, then here to be 9. So now what this one is going to end up with, I mean what I have here is going to be something like this. I'm going to have the y, then I'll pick the sign that I have here, which is what? Which is the minus. Okay, that's the minus. Then minus 1. This one that I've picked it from here. Then I'll put what? I'll just say squared, like that. Then I can pick the other part that is remaining, which is 1 squared. That's it. That's like that. Okay, so that is equals to 36, like that. Okay, so how does this one end up to be? So that would be 5x squared. Just a minute. Okay, so that would be 5x squared. Then here you're going to have 9. Then you distribute the 9 with everything that you have inside. That's going to be like y minus 1 squared. That would be minus 9 is equals to 36. So here you're still going to have that would be your 5x squared. That would be plus the 9y minus 1 squared. That would be equals to. So here you are going to add 9 on both sides, or you just take this 9 on the other side here, and it's going to be plus. Okay, so that's going to be like 36 plus 36 plus 9. That's going to be like 45, I believe, like that. Then we have not yet gotten our standard equation, so you can divide both sides by 45, by 45 here, by that side 45 as well. So we are close to the what, to the standard equation. And this might look like I'm taking a lot of time, but this is actually very quicker when you are doing it yourself, since you don't have to be explaining to anyone as I'm doing. Like, you just be like answering on your own, so it will be much quicker compared to it appears I'm taking a lot of time. So here, um, yes, Natasha. Sorry. It's Natala. Sorry, I'm really sorry. I thought it was Natasha. Sure. Yes. Minus 1 over 2. Yes. Or you're wondering where the negative went? Oh, okay. Sure. Okay. So this is what I'm remaining with right here. So we are remaining with 5x squared over 45, and you observe to say 5 into 5 is just a 1. Okay, that's just a 1. Give me a minute. Okay, so there it's just a matter of dividing, more like simplifying it. How many times does 4 go into 45? So meaning we are going to have like x squared divided by 9, yeah? then plus, then here I'm going to have the y minus 1 squared, that is divided by uh like yeah, that would be 5 here. Yeah, is equals to 1. So this one right here is the standard equation that we were looking for. Okay, so from this standard equation, we don't really need to sketch. The question was just asking us to find the center and the foci. Okay, so the center is quite evident to say. The center is supposed to have the coordinates h comma k. Okay, so the h part is one that you get from the x, because initially the standard equation of the circle that I'm going to give you, one that is translated, is one where it's like x minus h squared divided by a squared plus, that would be y minus k squared divided by b squared is equals to 1. So it simply means we just have to look at what you have at this point. It simply means what we had there on the x part was the h was equals to 0. So for the center you have 0 comma, for the k is positive 1. Okay, so you need to be careful. If you have a plus here, meaning it was going to be a minus, so you need to be very careful here. Just all you have to know is this format here. If you know this format, then you never go wrong. So that's our center right there. Then what else do we need to find? We need to find our what is it looking for, the foci. Okay, so for the foci, like there are two sets of since this is an ellipse, there's f1 and f2, but foci is just more like prudence, singular, focus. So how we get our foci is that we first of all again have to know about the orientation, because you can't just start guessing to say okay because there's a time when the focus, or let me say the foci, is going to have, like, let's say it's h comma k plus or minus c, and there's a time when it's f you have h plus or minus c comma k. So you can't just guess to say maybe it's this one or maybe it's that one. There's no guesswork, because everything that we have on the standard equation, it tells us about the orientation. If you know the orientation excuse me, you're going to know which of these coordinate system you're going to use for the foci. Okay, so now looking at what we have here, my value of a, okay, my a squared is equals to 9, my b squared is equals to 5. So one thing that I observe here is that my a is greater than my b, of which it tells me that I'm on what? I'm on the x-axis. Okay, meaning this is oriented on the x-axis. So this is these are the coordinates that you're going to use. Why am I saying so? It's because instead of when it's not rotated, you could have said focus is just has like a positive or negative c comma 0, but because you have shifted it in, like, it's more like in respect to the major axis, which is the x-axis, you look at this h here. Okay, that's why it's this set of coordinates that we're going to use. I'm not sure, I don't know if that explanation has made sense. So that's basically the importance of us knowing the orientation before we even do anything, because if you use guesswork, you might use the wrong coordinate system, and actually if you use the wrong one, it might affect your graphing. If this question was asking us to graph in terms of the Cartesian equation, but unfortunately the question was asking us to graph in terms of what's this parametric equation. So here we just have to know what your h is. Your h is 0. Okay, that will be 0 plus or minus. You have to find what your c is. This is comma k, which is a 1. So for this part, for me to find what my c is equals to, I just look at, okay, my c squared will be equals to the major axis value, okay, which is my a squared, minus the minor axis, which is b squared. So that would be c squared will be equals to 9 minus 5, meaning c squared is equals to 4. So my c is nothing but positive or negative 2. So that is what I put there. So these are the coordinates for the focus, where if you want you can write them as, okay, I have my f1 as minus 2 comma 1, then I have my f2 as positive 2 comma 1. Then these are what you are looking for. That's where the 7 marks was coming from. Complete the square. After completing the square, it tells you where the center is. You get the coordinates of the center. Then you look at, before you get the focus, try to know the orientation first. Don't just get anyhow. Know the orientation, because the focus depends on the orientation. Is the ellipse oriented on the x-axis, or is it oriented on the y-axis? if it's oriented on the y-axis, the coordinates are not going to be the same as if it was oriented on the x-axis. So that part is very, very important. You have to take note. Any question on this part before I continue? Okay, silence means people have understood. I'm glad you have. So the next one is asking us to parameterize parameterize the conic section using the angle theta as the parameter. So what it is that when you are when you if I was to give the most basic example of a Cartesian equation, let me give you something like, let's say y is equals to, let's say x plus um, let me say actually let me say 2x plus 3. This is very basic actually. So what I would want to do is that this is in terms of a Cartesian equation. Let me try to try to parameterize this. So what it is now here is that my y is in terms of what it is in terms of x. It's more like y is equals to f of x. Okay, so just a minute. Yeah, my y is in terms of x. Like my y is the dependent is a dependent variable, then x is the independent. Y depends on x. Whatever happens to x, like it reflects the result on y, depending on the type of function that it is anyway. So what it is here is that if I to parameterize this one, I'll just pick the most basic thing that I can do on this one is that I can just let my x be equals to, for example, if I want my parameter to be t, I can just let my x to be equals to t like that. Okay, so meaning the x is t. This is one of the parametric equation. This is the first one. It's as simple as that. Then the second one, okay, the second one is going to be equals to or just come and say the y will be equals to, where this x you just substitute with t, substitute with t, that will be 2t plus 3. So these two are the parametric equation for this one right here. Okay, so if you want, you can still do the reverse thing. It still take you back to that one there. Of course, this is not, we're not going to use the same steps as I'm showing you right now on this one. It's because it's a bit different, but I'm just trying to show you how basic converting from a Cartesian to parametric is, or from parametric back to Cartesian. So for this one here, you should keep in mind to say, if you look at there was a question in your tutorial sheet. I think it had what did it have? I think it had something like y was equals to cos something, but the angle for cos and sine they are the same. Let me just say cos a here. Then I also say x is equals to um, sine a like that. So if I have this in terms of a parametric equation, if I want to convert this to a Cartesian equation, how I do it is very simple. So here the way it's going to be is that I'm just going to square both sides, okay, of this. So this will be more like when you square this side of y, that will be like y squared is equals to, you square that one, that will be like cos squared a. Then here you're going to have x squared is equals to um, that will be sine squared of a. So when you add both sides of this, where you have like your y squared plus your x squared will be equals to, add cos squared and sine squared is going to give you a 1. Hence we have converted from parametric to what, to Cartesian. And this the same applies to, you might ask to say, hey, wait a minute, what if, yes, uh-huh, what's the question, sir? Alfred, is it Alfred? What's the question? Okay, you ask sometime later maybe. I'm not sure if you're able to hear me. No, this is just an example. Yeah, I understand the confusion, but this is just an example. You can swap these, you can put sine here, you can put cos there. This is just an example. So this a similar thing would be true whereby, let's say at this point, let's say this was like y plus, let's say y plus 2, or in other words, let me put it to be say, let me correct the confusion here so that at least all of us are going to be at peace. So let me say y is equals to sine a, or let me say sine alpha actually. Then let me use x to be equals to cos alpha there. So what it is now is that if let's say this was y is equals to sine alpha plus 2, okay, this, there's no difference, like guys, like it's still the same thing. What you are going to do is that this is still going to be like y, then you're going to say minus 2, this side is equals to what, is equals to sine alpha, like that. Then what do you do when you square both sides? This is going to be like y minus 2 squared is equals to sine alpha there, sine alpha squared. So now if I give you this, I'm giving you hints right now of how this one is going to be. So this one here, let me give you actually the two equations, how they are going to be. They are just going to be more like your x will be equals to a cos theta, a cos theta, then y will be equals to b sine theta. Okay, so now to make sure to say everything here, when I have my parametric equation, if I want to convert them back to Cartesian, they give me the same thing. Try to observe what I have done at this point. Okay, if I have sine squared alpha, okay, meaning I've shifted, it's more like y has, the y is moving in terms of like with 2 units because it's been translated. I don't know if you understand what this one means here. So the same thing is going to happen here. Okay, so this a here and this b are nothing but what, these values that you have here. Okay, are nothing but these values that you have, which is this one and that one there. Okay, so here you are saying your a squared is equals to 9, meaning your a is equals to what, your a is equals to positive or negative 3. Okay, but for this one here, your a is just more like it's representing the radius. Okay, remember to say you are, there is also a time whereby you are saying your x is equals to r cos theta, but I don't want to use r, or in this case I want you to take your a and your b as your radius. Okay, so for this one here, I would like it to say you just take your a and your b in terms to be what, to be your r. That's how you're going to simplify your work. So how you find your a and your b, I believe we're already able to see what they are. So here our b squared is equals to 5, meaning our b is equals to positive or negative the square root of 5. So now here someone might think to say, now since it's positive or negative b, which one do I pick? It's very simple. Since you are saying your a and your b is as in terms of the radius, and radius is nothing but the distance. Okay, so meaning this is just going to be more like you're going to have your a, I mean your x is equals to, your x is equals to your a, which is 3 positive 3 cos what, cos theta. Then your y will be equals to your b, which is the square root of 5, sine what, sine theta. But here is a catch. There's something else that you're going to add here. That is a what, that is a 1. So these two here are the what, are the two parametric equation for what, for this ellipse that we have here. If you want, you can try to convert this back to what, to this one. You're still going to get the same thing. It's because this one will remain the way it is. Okay, it remains the way it is. Then this one, the 1 is going to shift. You're going to have like 1, y minus 1 is equals to the square root of 5. Then you have what, you have your sine squared there, sine squared theta, like that. So just make sure to say if if your ellipse or any conic section is not centered at the origin, or if the vertex is not at the origin, if it was a parabola, make sure you cater for that part that has been translated. Are we clear on that one? So looking at, since we're using theta as our parameter, you can come up with your parameter intervals. If you look at what I have here, there is no limitation basically. I'm just moving from 0, um, let me put theta there, 0 to what? To 2 pi. You can include those. Then you can use this interval to what? To sketch. That is going to give you your ellipse, and that is the part, that is question 1-3. We just use that interval, and the way you're going to write it is something like this. How you come up with your coordinates, it's going to be something like, you're going to put your theta here, because your x and your y is going to be dependent on your theta. Then you have your x, then you're going to have your what, then you're going to have your y this side, like that. So for example, you choose 0, put 0 here in terms of cos. When you put 0 here, you're going to get a 1. You're going to get a 1 at this point. At this point, you're going to get, I believe it's also a 1. So you just use this same method. You come up with a set of points. That's the one that is going to help you to determine, as the question says, given that the particle p xy of a part of given that the position pxy of a particle moving in the xy plane is given by the parametric equation found in part B, which are these two. Sketch the motion of the particle. So these right here, these coordinates that you're going to get here, are the ones that you're going to use to sketch the motion. They are the ones that are going to tell you more like the direction in which you are moving. Are we clear on that one? um, I'm seeing people joining back and forth. Maybe it's network, but don't worry, the class is actually being recorded. Yeah, so you don't have to worry. Just in case your network is not working, okay, I'll upload the class just after we are done here. So I'm going to question 1b. Okay, so question 1b, what I'll do is that I'll help you find question b1, that is just the angle, and I will show you what you need to do to find the values of x and the values of y. Okay, so that you rotate, because the rotation part was carrying 8 marks. There was no need for you to sketch, I think. Okay, so what it is that you were given x squared divided by 2 plus xy plus that's y squared divided by 2, then that's minus y divided by root 2 plus x divided by root 2. So now remember to say here, the first thing that the question is asking you to find is find the angle of rotation of axis for eliminating the cross product terms. The cross product terms that you're talking about are these two right here, these ones here. Okay, so how you find the angle is that you can use cot 2 theta or tan 2 theta. Whichever that you use is still going to give you the correct thing. So let me use cot 2 theta. So cot 2 theta is nothing but a minus c divided by b. So how I get my a and my b and my c, it's very simple. The coefficient of the x squared is my a. Coefficient of xy is the b. Coefficient of y squared is what? Is the c. That's how we do it. So meaning here, I'm going to say this is equals to my a. Okay, my a is 1 over 2, which is a coefficient of x squared, minus a c, which is also 1 over 2, divided by b, which is a 1. So observe that at this point you get 0 divided by 1. This one here is going to give you a 0. So you might like, wait a minute, why am I getting a 0? Like, what angle am I going to use? This is very, very, very simple. Let me simplify it. Let me even simplify it further for you. So you observe that what you get here is nothing but what? Is nothing but a 0. But one thing I'd want you to remember is that cot 2 theta or cot theta is just the reciprocal of tan 2 theta or tan theta. Meaning cot is just cos, it's just more like cos 2 theta, divided by sin 2 theta, like that. This one here is equals to what I have right here. But you might like, okay, I know that, but So what? Like, how is it going to help me? Let me show you how it's going to help you. Considering the fact that I had 0 divided by 1, it tells me to say I was on some axis whereby cos was 0 and sine was 1. That's where it gets interesting now. This is simply because you basically have the x-axis and the y-axis. Okay, you have the y-axis like that, and the x-axis like that. Okay, so how this one is going to be is that um, this one is our y. Wait a minute. This one here is our y, and this is our x. So it so happened to say we are in between these two axes. We are in a certain axis where cos was 0 and sine was 1. So it so happens to say, if you have done the unit circle, if you still remember the unit circle, it's the y-axis, because that is where cos is 0 and sine is a 1 and negative 1. So it's where you have like 90 over 2. Then here you have what? You have 3 pi. Sorry, that's pi over 2 giving us 90. Then you have 3 pi over 2 giving you 270. So if you say sine 90, you're going to get positive 1. Then sine 270 is going to be minus 1. So it's obvious that the angle that I'm dealing with is what? Is 90. So I'm simply saying the angle that I'm talking about, which is the 2 theta, is equals to 90, but I'll write it in terms of radians, which is pi over 2, like that. So you want to find your theta, not your 2 theta. So your theta will be equals to pi over 4, which is 45. So this is the angle that they are looking for. That was where the 1 mark was coming from. Any question before I continue? Do you have any question before I continue? The last step. Which one exactly? Which last step, madam? The okay, when I introduce the cos and the sine. Okay, so what I basically did is that, considering the fact that I had a 0, and this is it's just a matter of us remembering trig identities. So you know that cot 2 theta, in terms of trig identities, it's going to be like cos 2 theta divided by sine 2 theta. It's just, I've just gotten those from trig identities. Okay, just give me a minute. Just give me a minute. Okay, sorry about that. We can continue now. Yes, yes. Sorry, I was just trying to update something. Yeah. So, Shiva, have I answered your question? I'm not sure if it's you or Sharon who asked that question. Okay, yeah. So I just got this from Trigger Identities. Oh, 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 oh yeah, yeah. I've managed to. I'm recording the entire thing. I'll upload immediately when I'm done. Okay, yeah. So that's how you. Sure. That's how you come up with what? That's how you come up with. That's how you come up with your angle. So the angle, that they were looking for, you say find the angle of rotation of axis for eliminating the cross product. That's the 45. That's how you find it. Of course, you might keep it on your fingertips to say it's 45, but I've just showed you how you come up with the 45 itself. Then the second part is saying find the coordinates of the focus. It's saying find the coordinates of the foci in the original. So basically, here you have to rotate this, and I believe I've done a good number of questions where we rotate the axis of a conic section. So what you do is here is that you just substitute this angle in the equations of the equation of x and y. So what it is that you are given one that is not rotated, which is your x is equals to um, this is going to be equals to what? What will be the equations for x? Come again, you said x is? You said x prime uh-huh, minus, yes, sine theta. Yeah, like that. Okay, so that's what our x is. Then I believe our y is just going to be equals to that's actually x as well. You're going to have like x prime, is it sine theta, plus y prime cos theta. So one thing that you have to keep in mind is that sometimes you might have someone, or you might find somewhere in a, maybe in a textbook or something. So instead of them using x prime, they're going to use capital letter X, uppercase X, then they put cos theta minus capital Y, sine theta there, like that, which is same as that one, which is going to be X, capital X, sine theta, then plus capital Y cos theta. So these and those are just one and the same thing. Whichever that you use, you're still going to come up with the same thing. So all you have to do now is that you have to find, you have to substitute where there's cos, where there's sine, substitute with 45. Okay, and how you find that 45, you can either choose to use a calculator, you can remember your special angles. Okay, so for your special angles, we have your 45 here and you have your 45 here. Okay, so this is actually going to be 1 1 and root 2, like that. So you observe to say, if you say cos 45, which is pi over 4, is going to be equals to 1 over root 2, then sine pi over 4, which is also So you're also going to get 1 over 1 over root 2. So just come here and say, okay, my x will be equals to, instead of putting cos here, I'm going to say 1 over root 2. That would be like your x prime over root 2 minus y prime over root 2. Then for the y part, um, y is also going to be equals to x prime over root 2 plus y prime over root 2 as well. Then these that you have, this one and this one, you have to substitute them in all of this, then you rotate it. Like as you substitute, as you expand, you're going to cancel out the xy term. Then just know that you have rotated. So I believe I've gone as far as this on this one. This is much information. You are going. It takes time to rotate. I don't want to waste much of your time. You can try to rotate it on your own. At least we know the angle. We have these two equations. Then we can rotate in it. Any question before I go to the next one? Do we have any question before I go to the next one? Okay, I'll just go to the last part of question 1, which is C. So I'm hoping the gentleman who was asking about question C is here. uh, the question C says find the equation of the conic section centered at, so we're given the center at minus 3 comma 0, and we also, yes, on the previous one. Is it on the previous one? Okay. Mhm. No, that's still correct, meaning you, yeah, meaning you have just rationalized the denominator of this one, because you find someone who is going to say, no, cos pi over 2 is simply equals to, they'll say root 2 over 2. This is this, and this one here is one and the same thing. You have just rationalized the denominator. So what you are saying is actually correct. Yeah, but myself, I prefer not to rationalize, because like I have maybe 5 extra seconds that I'm going to use to rationalize, then I can just take it the way it is and just plug it in. Yeah, but actually, if you're able to, if you are okay with putting the root on the numerator, do it. Just make sure to say anything that you do when you're answering a question on rotation, make sure it's effective enough and it's time saving, because these questions, as you observed, I'm not sure if you took like if you took little time solving this question in your quiz, thumbs up to you. But for myself, I will not lie to you, I used to take a lot of time on this question, so I used to try to find the easiest way possible. Like, I'm trying to make my life much easier when it comes to this one, because like, let's say it's a test, you have 2 hours and you're given a question that is as ugly as it is looking, but you're able to rotate it, then maybe it will take you like maybe 30 minutes or something. And imagine if you did something where you make a mistake, and it might cost you a lot of time and you might not finish, and it's painful, whereby you're able to get a B plus or an A or an A plus, then you fail because of not finishing. It hurts. Yeah, so what you're saying is true. It's okay. Can I go to the next one now? Okay, so sure. So we have been given the center at we have minus 3 comma 0, and that's our center. Then I've been given the eccentricity E is equals to 3 over 2. Then we have also been given the foci at minus 3 comma plus or minus 6. Okay, so this is just asking for the standard equation. It's just saying equation, but obviously it's the standard equation. First things first, identify what type of conic section are you dealing with. and you simply look at the what? Simply look at your eccentricity. So you observe to say your eccentricity is equals to 3 over 2, which is nothing but 1.5, which is greater than what? Greater than, do we refer it in terms of 0 or in terms of 1? It's actually in terms of 1. So since our eccentricity is greater than 1, we know that we are dealing with a what? With a hyperbola. So this right here is a hyperbola. So we have gotten that from the eccentricity. That's the first step when you know the conic section you are dealing with, because like when you just think of say conic sections, there are four of them. You have the circle, ellipse, hyperbola, parabola, and each of them have different, like their equations are unique. So like wondering say, okay, which one is which? So just by knowing this, okay, it's hyperbola, meaning you can forget about the rest, then focus your attention on the equation of the hyperbola. So now, since I've known that it's a hyperbola and it's the center is not at the origin, I can write it like this. There are two of them. It's either is x minus h, um, is x minus h squared divided by a squared minus y minus k squared divided by excuse me, b squared is equals to 1. There's also another one, that is uh, that's actually y here, y minus k squared divided by a squared minus um, x minus h squared divided by b squared is equals to 1. So just identifying that is a hyperbola was one step into us winning the battle. The second one is which one of these two is the one that we are going to use. So how you are going to know the one you're going to use is know the orientation. And it was nice enough that they gave us the focus. So considering that the focus is like, because the coordinates of the focus are what is supposed to be more like, looking at, since here is plus or minus, it's quite obvious it was more like you had your h comma k plus or minus c. This is what it means. So it simply means this was oriented on the what? On the y-axis, considering the fact that the focus is affected by the k value. If it was affected by the h value, it could have been oriented on the x-axis. But since it's affected by the k value, it's because I've seen to say they have put it on this side. So it's like minus 3 comma that one. So this is my h and that's my h here. So this is oriented on the what? On the y-axis. So it simply means the one that we're using is the second one here. So it's very, very important. These little details, they matter a lot, because it's very easy to make a mistake on such simple. This question is very simple. It's very easy to make a mistake even when it's very simple. So just try to make sure to say you pay attention to those details. So here I'll say it's my y minus our k. Our k is a 0, so I don't need to put that 0. So I'll just say it's y squared divided by, oh wait, I haven't yet gotten my a and my b. Okay, here's how we get our a and our b. So since c is equals to plus or minus 6, meaning c squared is equals to what? C squared is equals to c squared is equals to 36. Okay, c squared is equals to 36. Then how am I able to use this? Okay, so e now is equals to should I look at it in terms of that? In terms of that, no. No. Let me not look at it in terms of this one here, because that C that I have on the focus is as a result of the the A and the B. So I want to look at the C in terms of the eccentricity. So the E, since E is equals to eccentricity, which is 3 over 2, which is C over A, it simply means my C is equals to 3, my A is equals to what? Is equals to 2. So what this one means is that C squared will be equals to what? It will be equals to 9. Then I'm getting that from the eccentricity. Then a squared is going to be equals to 4. So remember to say c squared is equals to a squared plus b squared. That's for the hyperbola. So for me to get my b, I'm going to say b squared will be equals to c squared minus a squared, of which this is going to be equals to my 9 minus, that's 9 minus minus our a, which is 4, giving us 5. So just come here and write to say this will be y squared divided by a squared, which is a 9. No, that's a 4, sorry. Yeah, that's a 4. Then that will be minus x minus h, that will be plus h, which is a 3 squared, divided by b squared, which is simply 5, then is equals to what? Is equals to 1. This one right here is the standard equation of the circle, sorry, of the hyperbola. So here, just focus on the eccentricity to help you to determine what type of conic section you're dealing with. Then from there, you can go ahead and find out what the orientation is. From the orientation, then you come up with your equation. So question 2, I'll be very quick on question 2. Question 2a says the conic section with the focus at the origin is given. So I say r is equals to 45 divided by we have root 3 plus 3 cos theta there. Okay, so this is the first part of this question, is asking us to identify the conic section. Okay, so how you identify is that make sure to say this is in terms of what? EP divided by 1 plus E cos what? Cos theta. What I'm trying to say is that make sure to say here you have a 1. Don't make a mistake to say you don't put a 1 here. So what I'll do here is that I'll say r is equals to 45 divided by, I'll factor out, or I'll force the 3 minus I'll force the root 3 outside, then I have to be like 1 here plus 3 over root 3, then cos what? Cos theta, of which this is just going to end up to be like 45 that would be 45 divided by root 3 divided by 1 plus 3 divided by root 3 cos theta. So here my eccentricity is equals to 3 over root 3. What's the value here? This value that you're going to get, I believe it's greater than 1. Is it? Yeah, it's actually greater than 1. So that's a hyperbola. So you have identified, and that was 3 marks. So just doing everything that you have done here and doing that's 3 marks for free. So the next one is saying find the equation of the directrix. So how you find the equation of the directrix is also very simple. You just look at this numerator here. So the p is going to give me the equation of the directrix. So what it is that, since I've determined that the eccentricity is equals to 3 over root 3, meaning my EP is equals to, you just pick what you have here, which is what? Which is this one here. So this one is equals to 45 divided by root 3. So you have your eccentricity, which is equals to 3 over root 3, then p here is equals to 45. Okay, that will be divided by root 3. So that can cancel out and that can cancel out. So you have p, which is equals to 45 divided by 3. So this one here, it's since this one is cos, okay, this one is cos, is on the x-axis. So meaning this one casts what? It casts the x-axis at that value there. And because it's positive, it makes sense to say, because it's going to open like this, so the value of the directrix is going to be positive there, because at this point you have 0, 0. This is a positive value, then you're going to have something there like that. So that this is the equation of the directrix. That's the eccentricity, which is greater than 1, meaning it's hyperbola. Then part B of question 2 says the cable of a suspension bridge is suspended between 2 towers that are 200 meters apart and 75 meters high. If the cable at its lowest is 15 meters above the bridge, what is the height of the cable from the bridge at 60 point at a point 60 meters from the center. So how this one is, that is just a matter of you trying to picture what you have. So if I have this as my bridge, yeah, then let's say the towers, I put my towers like that. So if you have a cable that's like this, I believe we have come across bridges that whose cables like they look to be something like that. So what it is that we have been told that these these towers are 75 meters high, both 75 meters high. Okay, 75 meters high. Then at this point here, this distance that we are given is what? The distance that we are given is 15 meters above the ground. Then the distance between them is what? Is been given as 200. So if you divide it by 2 at this center here like this, you have 100 on this side. Okay, it's a 100 meters. So you are looking for what the height is at 60 meters, at a point 6 meters from the center. So it's like this is the center, you go this side 60 meters, maybe like for example somewhere here, you're looking for what this height is. Okay, so what you do here is that this is parabolic. Okay, this is just going to be like x squared is equals to it's supposed to be like 4py like that. Okay, so what will happen now is that we're going to have to find the value of what? The value of p, because if I find the value of p, okay, if I find the value of p, it will be much simple for me to find what the y is, because at some, when you're looking for that height, you're looking at it in terms of what? In terms of y. Okay, so how this one is going to be is that you're going to say your x, you're going to have to find what your p in terms of this point is equals to. Okay, so I'll pick what I have here. The coordinate as the coordinates at this point is what? In terms of x is what? Is 100. I'm picking from the center, like this point here. I'm picking from the center, is 100 squared is equals to, that will be 4p multiplied by y. What is y at that point? Is 75. So that's like 100 squared, which is 10,000, is equals to, that would be 4 multiplied by 75 p there. So your p is going to be equals to 10,000 divided by 4 times 75. What are you going to get as your p there? What are you getting as your p? Yes, you said 33 point. 33.3. Okay, so when you come back, since your value of y at this point is quite obviously 75, you are going to have to try to find your value of what? Your value of your value of your value of what's this? Your value of y somewhere at this point. So it's more like from here to here now it's going to be what? It's going to change from 100 to what? To 60. So you're trying to look for what is at this point, like what the value is there, right there. So since x is going to be equals to 6, that would be like 60 squared is equals to That would be 4 times the p, which is the value that you find. So your y is just going to be equals to 60 squared divided by 4 multiplied by the p value that you're going to get. So that's this part here was just helping us to get the value of p. Okay, so from the value of p, then we use it to come up with the value of y at another point. Is that clear? Any questions, ladies and gentlemen? Do we have any question? Okay. I guess the silence means people have understood. If you haven't, you can still try to check out the tutorial videos that I sent on these questions. So the last part is asking for, is saying the orbit of the asteroid Apollo, um, with the sun at one focus is approximately given by 9 over uh, wait a minute. So that's 9. R is equals to, is given us 9 over 9 plus 5 cos theta. Okay, so what this one is asking of us to do is to we have to wait a minute, approximate given by that, where r is measured in astronomical units, find the longest distance of the Apollo from the sun. So here we are looking for the maximum distance. So looking at the marks that are given, you would choose to use differential calculus, or you'd use to choose the you'd choose to use the easiest method that you can ever use at this point, which is so what I mean by using differential calculus is that I can choose to find, since I'm dealing with two variables, this is r and theta, I can choose to find what my dr d theta is. Then when I differentiate this with respect to theta, then I equate it to 0 so that I get critical points. But I mean, that would be, I think, too much work to do. So what I'm going to do is that I'm just going to see what value of r is going to give, I mean, what value of theta is going to give me the maximum value of r, because I'm just looking for the value of r. So now, considering the fact that this is cos, okay, since it's cos, like cos, we're dealing with the x-axis, and of course the two angles on the x-axis that we talk about are what? The two angles on the x-axis that we talk about is pi as well as what? Pi as well as 0. So I'll substitute with pi as well as 0, so then I see what value that I'm going to get. Okay, so if you come here and say r is equals to 9 over 9 plus cos 0. Okay, so this is going to be 9 over 9 plus 5, which is a 14, like that. Then that is when I substitute with 0. If you substitute r with pi, this is going to be equals to this is going to be equals to 9 over 9 plus 5, then cos pi, which is minus 1, that will be equals to 9 over 9 minus 5, which is a 4. So between these two values, one of them is what? One of them is maximum, one of them is minimum, and you have found what your maximum and your minimum, what your maximum is. So just pick the one that is big, and I believe it's this one here. So this was what your quiz was all about.